my name is Armstrong. By day, I'm a Linux administrator, so I've been in technology since I was born. I actually learned how to use a mouse before I learned how to talk. So I've always been fascinated with technology. Took apart VCRs, did all that stuff when I was a kid. I remember going into Radio Shack when Radio Shack existed, and it actually had components. And I remember walking in there, and there was just an entire row of all these different things, capacitors, resistors, project boards, all this kind of stuff, and it looked like so much fun. But there was a huge disconnect between actually putting this stuff together and having the software to work with it. I mean, back in the 90s, you really just, unless you had your own programming or you had access to microcontrollers, you really couldn't build this stuff yourself and do anything with it. So with the introduction of the Arduino and the Raspberry Pi, it now gave me the ability to tinker. And ever since the last 2 or 3 years, I've been tinkering and trying to automate everything in my house, sometimes to the alienation of my family when things don't work and lights flicker on and off for no reason, which was kind of a contentious problem at one point in time. But so for me, IoT is about solving problems, right? Problems you didn't necessarily know existed, but solving problems nonetheless. So I'll give you an example. A year and a half ago, I bought a house, and every time we looked at this house, the sub pump was running, right? Every time we looked at it. Didn't think anything of it first couple of times, maybe it rained the day before or whatever. But on that third or fourth time, it's like, okay, there might be a problem here, right? So my first thought as an IT person is, this is gonna fail. This is gonna fail eventually, right? So I've gotta monitor this thing, because it's gonna fail at 2 a.m. when nobody's gonna hear it, and I'm gonna have an indoor pool in my basement, right? So this is gonna fail. So I've gotta monitor this thing. So I've been tinkering with the Arduinos and Raspberry Pis for about 6 months, like, first project, let's do it. Let's get involved. So I actually built prototype number 1, which is super, super awesome here. You can see it went through its ringer. But basically, it was just an Arduino board, and it had a couple of different water sensors on it. And these are analog water sensors, so I could actually monitor the height of the water on the first sensor. I took all this data, I actually sent it over to a influx database, which is a time series database, so I could actually look at where the monitor, or where the water was on the actual sensor itself. So if I'd have brought my stuff with me, you could actually see where the water was coming up, it would hit a peak, and then the sub pump would engage and water would get sent out. So I could actually monitor not only when it was happening, but how often. So it's like, okay, so when's this thing gonna fail? I know it's gonna kick off. Okay, it's happening once every 2 minutes, once every minute, whatever it is. Now I can actually replace this thing before it fails. And I've got another level that tells me when the secondary kicks in. So okay, sends me an email, hey, you might want to be concerning yourself about this. Secondary's in, let's get to work here. And then there's a third sensor, if stop what you're doing, get down to the basement, let's go. And that would actually call me. So I sent that out to Toledo, and it actually sent me a phone call or a text message, right? So again, to me, IoT is about solving that problem and taking that data and doing something interesting with it, right? So after this thing started to fail because of the actual minerals that are in my crock kind of ate away at the sensor, as you can see, I went with version 2.0. And unfortunately, I need to talk to you guys about a 3D printer because I got to use project boxes, but I developed another way to do it with just actually sending out an audio pulse and then waiting for the audio to come back and then monitoring the actual water that way, right? So I still get the same data, I can still report on the same stuff, it's just a different way to do it. So again, this is where the IoT stuff to me, it's like, that video of the boy that beeps, when he was the baby and there was a little monitor that was going off, there's actually a sensor called, I think it's called the owl sensor. And it will tell you when heart rate decreases or when, temperature starts going down, stuff like that. It's like, that's perfect. That's that kind of stuff that I'm really interested in, right? Solving that problem. One of the other ones I have, and it's actually a project that I'm working on right now, and I'm still kind of working through, and it's becoming a little bit more involved than I had anticipated, but, January in Ohio is nice and unpredictable. Today it's 2 degrees, tomorrow it's 30. So my house, again, it's all kind of circulates around my house because that's where all my problems come from. The heat and the heating rather in January, each room is different. If I walk into my daughter's room, it's 5 degrees cooler. If I walk into our bedroom, it's 10 degrees warmer. How do I control this? I can go to each room and try to mess around with the registers and try to turn those up and down and stuff like that. And then I'm just creating more of a hassle for myself. Because then if it's super cold, then I'm the one to blame, right? I turn the register off or something like that. So what I'm trying to design right now, and this is just kind of a prototype one that I built mostly for this talk, but just so that you can kind of see it, it's utilizing a couple different sensors, and the idea is that this is going to be in each room. It's got a temperature sensor, it's got a humidity sensor on it, it's got a motion detector on it on the front, it's got a PIR sensor, and it's got a gas sensor. So I can detect smoke, I can detect carbon monoxide, I can detect temperature, humidity, all that stuff, and then I can send that back to my server, right? And now I can actually adjust those registers based on a weighting system, right? So if I want the whole house to be 70 degrees, I now know what my weight is to be in each room, right? Single stepper motor on each one of the registers, and now I can actually control those myself as well. So now I can actually turn those up and down just using my sensor, using that data. If I port that out to like an AI, now I can do predictive analysis and say, okay, normally nobody's in this room on Monday, Wednesday, and Thursday, right? Let's not even bother with it, just turn it off. And as it learns, it gets better and better and better. And I'm using very, very simple components. It's all software. And these components aren't super expensive, right? They're readily available, and it's really just, what do you want to do with it? And it's been a lot of fun, and they're making it really, really easy to do. So I run all my stuff in-house. I know Jordan was talking about like security with IoT. Using that consumer stuff, it's scary, right? Like you don't know like how often is this stuff updated, what's it connecting to. I bought some cameras recently, and I ended up having to hack those because they were talking to server out God knows where. I had no idea what it was doing. So actually it's on its own subnet, I've got no internet access, and it's like, you don't know what these things are actually doing. That's why I like writing my own stuff. Like all this stuff it's your own code, you know what it's doing, there's no other way to get to it, and you know it inside and out. You can do anything with that data you want. So, and there's a lot of back-end processes that are involved, but still, you get a better result, I think, out of it than, you know, just plugging something into a wall and not really knowing where it's at. There's a lot to be said for that, right? It's easy, but you still kind of lose some of that knowledge of really what it's doing. Another one of the sensors that I built was, you guys were talking about when somebody comes in and wants to access a machine, it's just a simple RFID sensor, right? So red light, green light. When I tap up against it, it goes red, it goes green. So that demonstrates how easy it is to just, it is one sensor in there, and it's hooked up to a Raspberry Pi. I can take that data, I can send it wherever I want. I can take that red and green light, send it up to a relay, I can open up a door, I can turn on a light, I can do whatever I want. These are very simple electronics. It's all the software that's there, right? And all this stuff is open source. I'm a huge open source guy, love open source. Because the stuff that's out there is so amazing what you can do with it. Like the Influx database, right, that is basically your time series database, open source. Grafana for dashboard, open source. MQTT for taking all of these bits and bytes and moving them around as a messaging platform, open source. All this stuff is there, and it's really, really, really easy to do. They've made it really, really easy. This sensor actually here, the 2.0 sensor that I used for the sub pump, I actually have set up also as a garage door sensor. Leave the garage door up all the time. Got yelled at for it constantly. Get home, garage door's been up all day. Now I actually have a sensor there that tells me when the garage door is up and down. And I can log in from my phone into my home server and see, is the garage door up, is it down, and I can tell. And with presence awareness at my house, now it knows if my phone's there, right? So if both my wife and I are gone, and the garage door is up, go ahead and close it. Or send me a text and ask me if I want to close it. Very, very easy stuff. And all this stuff is self-contained. There's a couple of servers that I'm running at home, but really you can run this stuff on Raspberry Pis. Now this is not resource-intensive stuff. And the software that does the home automation stuff, open source. Super, super cool. Called Home Assistant. You gotta check it out. It's actually really, really cool. One of the other projects that I do is, I love to homebrew. I'm not very good at it, but I like to homebrew beer. So one of the sensors that I want to work with is, how do I tell if the beer that I'm making is actually reaching the alcohol level that I want it to, right? Is the yeast working? Has it kind of died out? Is all that stuff doing what it's supposed to be doing? So there's actually a group, I can't remember exactly where, but they actually designed a sensor that you can put in the beer as it's fermenting, and it will actually tilt. And as it's tilting, it'll tell you what the ABV is on it. So it's stuff like that. Again, it's solving those problems. right? I built a temperature sensor for when I'm actually brewing that will tell me what the temperature of the beer is. It'll tell me, exactly what stages I'm doing it, so I know what my strike temperature is, I know what all that stuff is. Again, very, very simple technology. So, for me, that's what IoT really is. It's just a way to solve those simple problems, do it with simple hardware. It's all open source. You can find all this stuff online. There's tons of resources out there. And that to me is really what IoT really is. Yeah, I think that's pretty much most of the projects that I had. So, is there any questions? Is there? Sure.
You went from phase 1 to phase 2
Mm-hmm.
in water sensor. Why did you do that again? We have a couple of sensors.
Yeah. So the problem that I had with the first version is whatever minerals are in the crop was actually eating away the sensor. So you can see on this guy at the bottom here all that corrosion. So the sensors are supposed to look like basically have gold strips. And what happens is as the water hits these, it changes the output of the voltage coming out of the sensor. So you read that voltage and you can see what the, where the water's at. This one got so eroded that I wasn't getting any measurements out of it because it was just submerged in the actual crop the whole time.
So those are resistance types.
Mm-hmm.
Okay. I know they make capacitance type water sensors too.
Mm-hmm.
That's interesting.
I just wanted something that was kind of contactless, just keeping it out of the water. You know what I mean? I thought about doing something like that. There's also ones that like as it will bend with it. Yeah, I saw that too. The HC-SR04s, the actual ultrasound sensors or ultrasonic sensors are really, really easy to use and they're really cool. They're really cool.
I think you'll be happy with the water level sensor for phase 2.
Yeah. So far it's worked out pretty good. I actually wish I would have had the graphanographs to show it because it actually is really, really cool how you can take that data and do some interesting stuff with it. I do the same thing with my the temperature data and the humidity data. I monitor and track all of it. So I can actually go on my phone right now, beacon into the house and see what my living room temperature is, what the humidity is, if my garage door is up again, if there's any motion detected in the house. So that's the other thing that I'm working at too is like a security piece, right? So I've got motion detection. I can do simple door sensors to see if the door is open or closed. And now I've got a security system. So, and it's all closed source. It's all closed system, I should say. It's all within my network. It's not going anywhere else. And I control it, which, my tinfoil hat is happy.
You mentioned MQTT. Is that on the Raspberry Pi?
So MQTT is actually a protocol. So it's, yeah.
It's served by Mosquito or something like that.
Yeah, no, since being a Linux guy, I got my own little server farm at home. I run that on a different box, but you can run that on a Raspberry Pi, no problem. Yeah, that's really easy to do. There's all kinds of stuff. You can actually run most of that stuff just enclosed in the Pi by itself and actually have just a web interface right to it.
As far as houses go, have you identified where the most savings could take place if a certain system was operating more efficiently, like whether it was the gas and the heating or the electricity? When you walk into, like you had said, there are certain rooms that are only used at certain times, so let's not have the air control lights at that time.
Yeah, you could, you'd have to have that, again, grabbing that data, you could do those analyses, right? You could say, okay, well, over the last couple months, I put this in, what's my cost savings? Electricity is really, really easy to measure too. A couple of Hall sensors, and you can see what your amp draw is, and you can test against that stuff as well. Like, where you're saving the most, I think our house is pretty inefficient right now. I'm really curious to see if I can get, if I can get this stuff up and running before the end of the winter months, what we'll save on it. Because we're running constantly, and quite honestly, some of the rooms, it's like, I don't know if the heat's on in those rooms, so,
Maybe just shutting the door, you could end up saving $50 or something.
Absolutely. In 1 month's time, you could save up all the sensor costs. And again, these little boxes, you can put them in each room. I think, what have I got? $15 in hardware costs.
I think if you could get it to put the toilet seat down, you could save it.
I'm waiting for that, yeah. As soon as I leave the room. That's actually not a bad idea. Not a bad idea. There you go. I'll have to write that down.
I had a question about, when you said you bought a camera that was like, sending data to some, obscure server, like, What are things to look out for so that doesn't happen? Like if there was someone like is, really good, wants to put this together, and sees them like running a netstat on their, like I have a friend that bought like a backup camera and put it in his car, and I'm thinking like, oh my gosh, what if somebody's I mean, it's a backup camera, but still, it's kind of scary.
Yeah.
What are things to look out for with that?
It's hard to tell exactly because a lot of these companies say, hey, it's plug and play. Put it in your house, turn it on, you're good to go. Don't worry about it. Don't worry about it. You'll say, Alexa, turn my lights on. It's going to turn your lights on. That's great. Don't worry about where else it goes. But these companies still have access to this stuff. I think it was it last year? Nest had a huge bug and like half the nests completely died for like 6 hours. People's houses went down to like 50 degrees. You had no control over it. I mean, this stuff is great, but I mean, everybody's fallible. I mean, you're going to make mistakes, and if you don't know exactly what's going on, you don't know. I mean, there are camera systems, there's all kinds of data that's getting sent out that you just don't know. I mean, Alexa, all that stuff's collecting stuff on you, 24/7. So it's hard to say like exactly what one thing or another is gonna, is something to look out for, but, I can't even say that price matters. I mean, sometimes even the most expensive stuff, they're going to take your stuff, or, the super cheap stuff, they take it too, so.
Yeah. And if somebody wanted to get into developing this kind of technology for themselves or for others, or just as a hobby, like what are the languages that are most common, and what are like some of the better tools that you want?
Yeah, so if you're looking to get started, the best thing is find a problem to solve. I mean, that's the easiest way to start figuring out exactly what you want to use. There's pros and cons to each one. You've got the two big players, which is like the Arduino and the Raspberry Pi. I actually learned Python just because that's what the Raspberry Pi used. So I had never actually used it until I found out that's what it used. I'm like, well, I gotta learn this now. I mean, here we go. So Python's a really good utility, or a really good programming language to learn. Arduino, the IDE that uses like C++, some C as well. So it's good to have that. But there are tons of examples out there. It's really, really easy to say, I need to interact with this sensor. How do I set it up? What simple commands can I give it, or what's a simple program that can run just to see it go? And then you can kind of extrapolate out from there what you really want to do and how you want to do it. There are tons of packages out there as well. So for a lot of my sensors, I actually send like UDP packets because they're quick, they're small. I don't have to worry about having an actual web server on the device itself. So there's a package for that, right? So I just import that library, I write a couple, lines of code, and off it goes. The sensor here that is basically the RFID sensor, the one that just goes red and green depending on what you're doing. I think it's 8 lines of code, 10 lines of code to do that, And, again, instead of turning a light on, you could open up your house. Be one command depending on how you write it. So there's lots of tools out there, tons of open source stuff. Depending on what you want to do, some really, really cool pieces of software out there. In fact, one of the ones that I use a lot is called Node-RED. And what Node-RED is actually developed by IBM. And it's a really, really easy way to tie in all these different pieces together, right? So you're getting TCP UDP packets, you're getting a webhook or whatever it is, and you can take that, you can turn it over into your messaging server, and you can do this with it, and it's just, you're creating these flows. And again, it's open source. So there's a lot of ways to skin the cat. So. Whoever wants to start, go ahead.
If somebody, more basic than the last question, if somebody knew nothing, and they said, I want to be able to do what you're doing, where do I go to look? Do they go to Google? Do they go to YouTube? Do they call somebody? Do they go to Best Buy? Where do they start? And sort of related to that, do you see things developing where there's expertise in this field, or is it going to become so widespread that everybody's doing it? Or perhaps a mix of both?
Yeah, I think it's a mix of both. I mean, you've got people, IoT is different for everybody. I mean, if you ask somebody that does it for a living, it's like, they're heavily into it. If you ask me, it's like, I just like to tinker with it and, type away, and here I go. A lot of the stuff, the way that I learned was just looking at other people's examples. So just doing a quick...
Where do you go to do that if you don't know anything to start with?
Quick YouTube search or on Google, and, there's a ton of videos out there.
You watch people do similar stuff on YouTube?
Yeah.
That's pretty much what you do.
Yeah, absolutely. The nice thing is not only is the software open source, but the hardware is open source too. So Arduino was actually developed to say, we need an open standard. So you can actually build your own Arduino. You can actually take an Atmel chip, you can do all the whole thing and build your own Arduino and program on it. So there's a ton of resources out there for you. I have a website where I kind of document this stuff as well, and I try to put pictures and source code and everything else, and people can email or if you had a question or something like that. A lot of the community is about teaching other people. So you can say, hey, I got a quick question, or post a question to somebody, and people are really good about getting back to you. So even if you're not sure where to start, it's like you can look up, how does an Arduino work, or how do I use a Raspberry Pi, and then just buy one and follow a couple of tutorials, load it up, and start playing with it.
What's the name of your website?
It's ToledoMaker.com. So I'm actually trying to do slowly but surely in all my free time. I'm trying to start like an open source Toledo group just for stuff like this, just for open hardware, open software, just for people to get together and just talk about, here I'm running this project, or here I'm running this server, because I love this stuff, and I don't have enough time to look at all of it, and somebody else might be doing something really cool that I'm not aware of, and so that's what I'd like to bring, something like that, like the old school lug back to Toledo. So is the goal anyway. So we'll see how it goes.
I think a lot of us are fascinated by the idea of Internet of Things, but it seems so far out. The kid who beeps, yeah, right, but like transportation, we have trains derailing because people are going too fast.
Mm-hmm.
That could be an Internet of Things.
Sure.
It should be. There's a lot of opportunities like that. But this last week, I had a really simple example. I was thinking about being here tonight, and something happened with my Fire Stick, and it lost, or my Roku, and it's lost its connection. And I had to go in and reboot some things and get things connected again. And I realized I have 10 devices on my home network.
Mm-hmm.
And I thought I had my wife and I have our cell phones. Like you said, who's got an internet? Who's got a thing that's on the internet?
Mm-hmm.
My garage door opener is just came out of the box, able to connect.
Yep.
So and
Where's that
itself,
Mm-hmm.
or ask you if you want to, call you. But like 10 things. Roku, Fire Stick, and it's all TV related. And I go, see, my dad was a rocket scientist for the Army, but I'm not. I admire what you do. I just like, oh my God, but I'm not. But it's coming in a box, people. It's gonna come in a box, like your Nest thermostat.
Oh yeah.
It's going to be coming in a box, and you plug it in your house, and then you go, but who's it talking to?
Right. And now you're part of a botnet that
That's already going on. That's already going on. Someone can drive by your house and pick up with Bluetooth or Wi-Fi your Roku, and have it can be on your local network.
Yeah, and these things are never, they're hardly ever updated, because once a company puts it out, it's like there's no cost benefit to us to update these things. So they put it out there.
The meltdown.
Oh yeah, oh boy. Yeah, being an administrator, that's a whole other source of it.
Brave new world, isn't it?
It is amazing though. In fact, a good friend of mine who we always have these back and forth discussions, because I like to tinker and do this. He likes to put down his money and plug it into the wall. He was telling me he had like over 50 devices on his network, and he had just put in like light switches and Philips, Hue bulbs, and it's like, I got 60 devices on my network. I have no idea what any of them are. I got 60 devices on my network. I'm like, you don't know what they're doing either. So, I'll take this stuff, and maybe it takes me, 2 or 3 months to develop something, and but I learn something, and then I know what it's doing. So yeah, I totally get it. It's scary sometimes.
Matt, how much do you think that costs total to build the device for your cell phone? And then how much is each individual sensor?
So these sensors are getting really cheap. I mean, you can really source these things out to get them. It depends on where you get them and what kind of quality you want to get them. I'm usually on the bargain shopper, right? So my budget for this kind of stuff is usually pretty small. But so, like for instance, this one, I think again, maybe have $20 worth of sensors total. Like the whole box, itself would be $20. The Raspberry Pi Zero W's, which is a really cool. I should have brought. It looks like a stick of gum, and it's a full stack Linux server. It's got wireless, Bluetooth, and I think it's got 500 meg of memory and single core processor. They can run most of these things I'm talking about right on the device, so no need to send it out. You can actually do it right on the device. The 2.0 version of the sun pump monitor is actually running a Raspberry Pi itself. And this is going to host the entire Influx database, the Grafana stuff, or whatever. I actually did it as a Christmas present to my dad, so I got to give it back. Unfortunately, I got to build myself one now. But the Raspberry Pi Zero, or the Raspberry Pi 3s are like 35 bucks. You know, so the stuff is really, I mean, pretty cheap.
What's the white stick?
I think it was like 50 cents, you know, for the stick. Oh, so the actual, this is kind of a wireless Arduino. So Arduinos by themselves aren't necessarily wireless. You can get them with the new chip is the ESP32 or the ESP8266. I think this whole board was like 10 bucks. And then the sensor, these are like 20 cents a piece. So it's really, you know, again, it's, yeah. So I have to be budget conscious. I mean, you met my wife. We beat you up on rent, so you know how that is.
Yeah.
You know, yeah. So I didn't think I got all this stuff, man. I was shorting out on rent for a while. So, is there anything else? Oh, sure.
So you talked about Arduino and Raspberry Pi, right?
Mm-hmm.
What makes one different from the other? How do you decide how to use Arduino for this project and like Raspberry for the other one? What's the difference between them?
That's a great question. So the Arduino is like a microcontroller, right? So it does, you can do a couple things, but it does something that does it very well. So when you actually look at the code for an Arduino, you've got basically a setup, and then you've got a loop. And that's all it does. It just loops and loops and loops. You can unplug it, you can plug it back in. You're not going to cause any like real problems with it. It's built as a microcontroller. That's what it does. It still can send data out and stuff, but the Raspberry Pi is better because it's a full stack server. So you're actually installing Linux or Windows if you have to. And then you can install, I mean, it's literally a full Linux box. So then you can do like your website stuff on there. You can do all kinds of stuff and put it right on that box. So the Raspberry Pi is like a full stack server, whereas the Arduino is basically just a microcontroller that just, you write, you know, some pretty low levels, you know, calls to it, and that's all it does. So it depends on what you want to do with it. So for a lot of my stuff, I've got servers at home that are going to do all my crunching and everything else. So I'll use Arduinos because I just want to do quick and dirty and fast, right? So if you have the full Raspberry Pi with the full stack, there's a time issue sometimes in there, right? So you don't get quite as quick, you know, response to it or something like that. Like, so when I press that button, if it doesn't unlock the door in 3 seconds, my wife's going to kill me, right? So if I actually put this in my house, so I need it to be not only quick, but then I need it to be, if the power goes out, I can't hold my whole house is corrupted, you know what I mean? So that's really where the Arduino and the Raspberry Pi, so they're kind of, they have their pros and cons. Some of them kind of bridge the gap to the other, they're getting better. The one thing I like about the Arduinos as well is a lot of them, I think the standard spec is you get one analog input, and then the bigger ones you get more analog input. So like with this sensor right here, so to measure that water, I'm actually getting a variable voltage coming out, so I have to look at that as an analog input. Raspberry Pis don't have analog inputs by default, so I'd have to get an analog to digital converter for that. Whereas the Arduino, I can do it right off the bat, and I get that, you know, super fast reading of it. So, hope that answered the question. I don't know if I went too far up. Okay. Anything else? Oh, sure.
A little more of a broad question. I don't know
Sure.
if it's really into your expertise, but the business about the power coming off. If more people are going to get more devices and poorer people are going to get more devices hooked up, what happens when the power grid goes down? Most people here could probably remember about 10 years ago, the whole East Coast, from here to East Coast had some little twitch and everything went dark for, I can't remember, some number of hours. But is this a concern, or is there a way of decentralizing a lot of stuff as we go? Is that possible?
Well, I mean, you're always going to be that, you're going to have that dependency on power regardless. I was actually stuck at a gas station for 8 hours in Cleveland when that power went out. That was a lot of fun. But I think you're always going to have that dependency. I mean, you're right, it's tough. As you start plugging in more things, if you're completely dependent on it, then yeah, power goes out, you're SOL. I always try to have that physical backup, right? So one of my things that I want to do is I want to have that key fob that will open the front door. I'll always have that mechanical thing that I can open up as well. So I'll always have that way to circumvent what I'm doing. One of the other things that I have a problem with, like as far as like the bulbs and that kind of stuff, is you put some of these smart switches in there, power goes out, the switch doesn't work anymore, right? Or if the wireless goes out, I should say, if the wireless goes out, then that switch might not work because it can't talk to the servers to tell it what it's supposed to do. I always have a physical backup. That switch always works without the device. So that's the other kind of rule of thumb that I try to do too. So, you know, power goes out, you're kind of SOL anyway. But if your wireless goes out or your internet goes out, the idea is to not be completely down. And that's more of a design. You just got to make sure that you allow for that kind of.
Retrofitting is an issue, man, when we have these homes that are built in the analog world and now we're digital. But in the smart home world, where these things are starting to come in packages, you have a low voltage network in your house, wiring system, just like you have a high voltage wiring system. And a lot of these things, a simple solar cell, a small one, can maintain a charge on the backup battery that can maintain your low voltage network. So I think we're going to see a lot more things like that. And the University of Toledo has some people that are working on, some storage stuff related to solar and low voltage systems. And I think we're going to see a lot more of that. But yeah, that's an issue when you retrofit.
Yeah, absolutely. I mean, and batteries are getting better and better and better. So, I mean, I don't think it's going to be unheard of to have, cells in your house that are literally just for something like that. I can totally see that. Sure. Sure. Mm-hmm. Yeah, absolutely. And that's a great point. It's hard to see exactly where you're losing some of that air too. Yeah, absolutely. And it's like, why is this room 5 degrees cooler? Well, okay, there's some older windows in there, or maybe some of the insulation isn't any good. Yeah, that's a great.
Check out Home Depot. I've been in my house for 10 years. They give me upgrades for our installation. All my rooms are.
I might take you up on that. Might be easier than the sensors. Yeah. I got another one over here. Oh.
There's a number of companies that have low voltage systems out there that work on batteries. Also, Wayne State has a DC house, which is all DC. Runs on solar, but it can also be tied back to the grid.
Yeah, that's really cool. That'd be really easy to add your own stuff, because a lot of times I'm having to convert AC to DC for all that stuff. So I should put a DC rail in my house. I'll have to check that out. All right, I think we have another question over here. Did you have a question? Nope. Any other questions?
All right, well, thank you so much, Matt.
Thank you.
Let's give Matt a round of applause.